Assalamualaikum warahmatullahi wabarakatuh. My name is Izul Aiman bin Izzuddin Effendi. My matrix number is 200625. Today, I would like to present to Dr. Amzari about radar communication and navigation. This is the list name of my group. Raji Izzuddin Shah, Amin Faik, and Razlan. Okay, let's go to the intro. Introduction for radar navigation and communication is it's widely used as a air traffic management. The objective of this infrastructure is to ensure the air traffic is safe and efficient throughout the world. Radar is mainly used as an air traffic controller and flight crew to determine the position of the aircraft and provide safe separation from other aircraft to avoid a collision in the air. After that, communication mainly as voice and data, which are accurate and timely are essential to air safety. Communication are generally delivered by a very high frequency and high frequency system and satellite communication depending on the location that support those type of communication. For navigation is like a ground satellite radio navigation equipment. It's enable pilot to use their instrumentation to fly precisely along their intended route and to conduct the precision approach and landing.
Assalamualaikum and thank you for my friend to the clarification about the introduction. Next, I will continue my point and I will give more explanation about radar. So before that, radar is stand for the radio and detection ringing. And the next point is radar is an electronic system which measure the range and bearing of object by transmitting an, an electromagnetic pulse at the object and listen for the echo. There are several radar used in the aviation industry. First one, aerial radar, survey radar, and approach radar allow to controls to track aircraft within their area of responsibility. The next one is precision approach radar, or we call it as PAR, enable control to provide precision approach guidance to aircraft landing in instrument conditions. The next one is surface movement radar. Surface movement radar enables to control to track the movement of aircraft and vehicle on an aerodrome surface. And the next one is weather radar. Weather radar gives the pilot situational awareness of the hazardous weather, especially thunderstorms. And next one is radio altimeter, accurately to measure the height of an aircraft above the surface. And the last one is secondary surveillance radar, to enable aircraft to pass additional information such as identification and flight level back to the integrating radar. Okay, as you can see over here, radar has used by ATC, and radar has two types of surveillance radar. The first one is primary surveillance radar, a system where the ground-based antenna transmits a radar pulse then listens for the small amount of return energy that is reflected from an aircraft. The next one is secondary surveillance radar. Respond to the pulse sent by the transponder to gain information from a flying aircraft, such as altitude and position. So that's all from me, and we continue to my friend to give more explanation about the communication. Thank you.
Okay, my name is Raja Izzuddin Shah, Biraja Muhammad Azhan Shah, and my metric number is 200963. Okay, now I will be presenting the topic navigation. Okay, navigation is the technology of determining the position of an aircraft with respect to the surface of the earth and accurately maintaining a desired course. Okay, so every flight, especially the commercial aircraft, their they have a flight plan which shows course, the path on which the aircraft will be flying. There are many methods to there are many methods used for navigation. The first method is dead reckoning. Dead reckoning method, which is the method of navigation relying on estimating the aircraft's current track, ground speed, and position based on earlier known positions. So take the current position and the speed of the aircraft, ground speed to to predict the time to reach the next location. This is even though is quite this is a traditional way, it is still used now by pilots to determine the ETA, the expected time to arrive at any certain location. The next one is pilotage. The pilotage method is navigating using fixed points of reference on land, usually with reference to an aeronautical chart to obtain a fix of the position of the aircraft with respect to a desired course or location. So the pilotage method, basically, the pilot will use a map and their eyesight to determine their location and the path of flight. So basically, the pilot will look for landmarks such as a river, sea, airport, or anything to determine their current location. The disadvantage of this method is because sometimes at high altitude it is hard to see the landmarks on the land, to see the reference points on the land. So this is quite disadvantage for the pilot. The next one is the global positioning system, which are also known as GPS, a more modern avionics navigation system, which is a space-based positioning, a velocity and time system, which is developed and operated by the US Department of Defense, and it is composed of space, control, and user segments. These are the three segments of the GPS system. So basically, the GPS connects with the satellites to get the current aircraft location, speed, and altitude whatsoever. And okay, the segment is actually used by different people, like for example, the user segment equipment, such as GPS receivers, displays, and antennas are usually used by aircraft technicians. Okay, the next one is the radio navigation, which is using the application of radio frequencies to determine the position of an object of the aircraft, basically on the earth, using nav aids or radio navigation aids. Okay, oh sorry. Okay, there are several kinds of nav aids. The first one is automatic direction finding, ADF, which is an electronic aid to navigation that identifies the relative bearing of an aircraft from a radio beacon transmitting in the MF or LF bandwidth. The next one is VHF, which is very high frequency omnidirectional range, or VOR. This is a short-range radio navigation system for aircraft, enabling aircraft with a receiving unit to determine its position and stay on course by receiving radio signals transmitted by a network of fixed ground radio beacons. The next one is distance measuring equipment, DME, which is a radio navigation technology that measures the slant range or distance between an aircraft and a ground station by timing the propagation delay of radio signals, which only work in the frequency band between 960 and 1215 megahertz. Next one is Instrument Landing System, or ILS, which is a system that works by sending radio waves downrange from the runway end, with aircraft that intercept it, using the radio waves to guide them onto the runway. This is basically used at uh, airport control tower to help the aircraft land on the runway safely, and also maintain the separation distance between one aircraft and another aircraft. Okay. These are the example. That's all. Thank you.
Okay, Assalamualaikum. So my name is Amin Faik Bezofahmi, 200438. So my part in here is the communication. So I will explain to you one by one about the communication in the avionics. So rather than we have radar and navigation, we also have communications, including the data, how it's everything about communication. So let's proceed with our slide. So introduction radar. So communication. So data communications program provides data communication services between pilots and air traffic controllers. It provides a digital link between ground automation and flight deck avionics for safety of flight, air traffic control clearances, instructions, traffic flow management, flight crew requests and reports. So as you can see, as we all know, the basic in communication in airport, we have the tower with the ATC, the air traffic controller, which communicate with every flight that fly in their regions to have the access into that area. So we have to communicate. So it needs to communicate with for the safety of flight. So how many altitude that flight can fly. So what is in front of the flight. So everything. So is it safe to landing and everything. And then if the flight requests for the flight crew request for anything such as you want to take off or everything. Yeah, so it involved in communications. So VHF communication system are employed largely for controlling the air traffic. These systems are installed in all types of aircraft, so the pilot may be given information direction and may be request information from air traffic control centers, control towers, and flight service stations, as I said earlier. So this is type of communication. We have VHF communication. VHF is basically stand for high frequency, very high frequency communication system. So largely for controlling the air traffic. So they basically installed in all types of aircraft. So it is not it is a specific communications to do with the ATC. So next we have the high frequency communication systems. It's a long distance communication system and are not employed on all aircraft. So that is the so HF. So for every aircraft, it have the HF antenna, as you can see in the slide here. In the slide here is the HF antenna. So it puts the antenna here so that it can communicate. It's basic in the communication system. We must have the antenna so that the signals can be sent to and sent back. And then you have the various antenna here, the antenna here over here, and then for the HF antenna, we have here. So this is the VHF system, but underfloor avionics bay here in the main bay. Okay, this the control center, the tower. So this is the plane. So this is nothing. This is just a facts. This is just information. It been mentioned by McDonnell Douglas DC-8. Okay, that is. I think that is for my part. So, thank you.
Uh, and to conclude, all the all about navigation, communication, and radar. Conclude from this subtopic. From this topic is radar, communication, and navigation is most important aspect and function in the aviation industry. Why? Because it uh it tell us where the aeroplane located, how to it kept our safety in the air, and when we want to landing in the airport and else. After that is it can increase aircraft capacity, especially in congested airspace. Uh, Furthermore, it can be a less disruption due to delays and diversion. Radar communication and navigation is also mean for ground staff as air traffic controllers to detect any emergencies and whereabouts the aircraft flying across the world. Uh, and lastly, it helps air traffic controllers to manage airspace safely and effectively. It's all about safety because safety is the first. Thank you.